Today we're going to be focusing on just drawing more of a general rational function. It's not necessarily going to have a real structure to each one. Like the ones we did on Monday, they all had two branches in opposite quadrants, and they all sort of followed that same structure. So there is one new piece that is not the same as what we've done before, and that's when you guys are finding your horizontal asymptote. So I'm going to write down an example here. So I gave you guys the function x squared plus 3x plus 2 over x plus 5. So if we're looking at this, the box here where it has your m and n values, this here at the top is really just a polynomial. Again, just not with any numbers being shown. But you're going to have to look at the exponents in the numerator and denominator. So your m. So if we look at our example, m is the degree of your numerator, and n is the degree of your denominator. So in this case, m is going to be 2 and n is going to be 1. So for each function, it's going to be different, but we're looking at those degrees of the numerator and denominator. So when your numerator degree is less than your denominator degree, m is less than n, your horizontal asymptote is at y equals 0. When m equals n, which is what we did in the past when we had like 3x squared over 1x squared, we divided those coefficients. That's what that's saying. So when they're equal, you want to divide your lead coefficients, and whatever that value is, that's the horizontal asymptote. So that's the one we've looked at already. And the last scenario would be if m is greater than n, which is what our example is, and that's the scenario where you have no horizontal asymptote, which is fine. So in your example, this one would have no horizontal asymptote because 2 is greater than 1. M is greater than n. The graph's end behavior is the same as the graph A sub m over B sub n times m minus n. So no horizontal asymptote there. So your three options are at 0, no asymptote, or you're dividing those lead coefficients to get the value of your asymptote. So it first has us just sort of working with an equation or a function without graphing it first. So if we're given this function x plus 3 over x squared minus 2x minus 3, it wants us to find the asymptotes and then your x and y intercepts. So the vertical asymptote is going to be when you're solving for your denominator. So if we set x squared minus 2x minus 3 equal to 0, I would go ahead and try to factor that. So x minus 3, x plus 1. So our two values are 3 and negative 1. Three and negative 1 would be your vertical asymptote. Your horizontal asymptote is, again, you're looking at your exponent, your m, and your n. So if there's not one there, you remember, it's x to the first. So in this case, m is less than n. 1 is less than 2. So when your numerator degree is less than the denominator, it's going to be at y equals 0. Your x-intercept is when you solve for y being 0. Remember, f of x is really just y. So what happens, guys, is you multiply both sides by x squared minus 2x minus 3, or you cross multiply, whichever you prefer. But what happens is you still end up with that left side being 0. So you always just solve, really, for your numerator equaling 0. So x plus 3 equal to 0. X equals negative 3. Again, sometimes we can have more than one, but in this case, it's only going to be one x-intercept. And then your y-intercept, set all of your x's equal to 0. So y is going to equal 0 plus 3 over 0 squared minus 2x. Or 2 times 0 minus 3. So 3 over negative 3 is negative 1. So your y-intercept will be negative 1. So that's really all there is to it. And you just sort of work through it. Each one the same way. Like I said, the graphs themselves will be a little bit differently, but the process is still the same. So we'll do the same thing for number 4. We've got the function 1 over 3x squared minus 4x minus 4. So for the vertical asymptote, we will solve for the denominator. So 3x squared minus 4x minus 4. Again, if you don't remember how to factor, you'll have to use the diamond and the box. But if we do factor this, it will be 3x, and x is the only thing to multiply to get you 3x squared. And then multiplies to get you 4, 2, and 2. 3 times 2 will be negative 6. 2 times x will be positive 2. And that will be factored. So we have negative 2/3 and positive 2. So vertical asymptotes at those two values. Okay, horizontal asymptote, looking at your exponents. In this case, again, fillers, guys. This can really be written as x to the 0 power. Because anything to the 0 power is 1 times 1 still leaves us with the value of 1 that's up there. So in this case, 0 is less than 2. M is less than n. What happens when that's the case? It's at y equals 0. Okay. X-intercept, set your numerator equal to 0. Or really setting y equal to 0 and cross multiplying. So you end up with 0 equals 1. What happens here, guys, when you end up with a false statement, there's no x to actually solve for. That's when you end up with no x-intercepts, which is perfectly fine. And then your y-intercepts. Any x you see, just make 0. So y equals 1 over 3 times 0 squared minus 4 times 0 minus 4. Which ends up just being negative 1/4. So just one y-intercept, negative 1/4. Same process every single time. The last one I'm going to do with you guys is number 5. Same thing again, but we've got the function now x squared minus 10x plus 5 over 3x squared minus x minus 2. So your vertical asymptote, we're going to set that denominator equal to 0. 3x squared minus x minus 2. Factor it if we can. And 2 and 1. And it has to be plus 2 minus 3. So we'll get x equals negative 2/3, and positive 1. Okay, so 2 vertical asymptotes, that's good. Now your horizontal asymptote. Remember, you're looking at your exponents. So we've got x squared and x squared, so 2 equals 2, m equals n, so we end up dividing. What's in front of your x squared? 1. 1/3. So 1 horizontal asymptote. And you'll never have more than 1 horizontal asymptote. I'm going to save the x-intercepts for last. I'm going to do the y-intercepts. So the y-intercepts is when you guys plug everything that's an x, or plug a 0 in for all of your x's. So 0 squared minus 10 times 0 plus 5 over 3 times 0 squared minus 0 minus 2. So we end up with negative 5 halves as your y-intercept. So the last thing we need to do is the x-intercepts. So this is where you guys plug or solve for the numerator being 0. You really plug in 0 for y. You would cross multiply, but that left side still ends up being 0, and you're left with it equaling your numerator. So x squared minus 10x plus 5 equals 0. We need to solve for this. Now, I always like to factor it because it's possible to factor it. Just if it's not possible to factor it, that doesn't mean you can't solve it. That just means you have to use the quadratic formula. So in this case, if you need to use the quadratic formula, which I'm saying we do need to do that, remember what your A, B, and C are and just plug it in. So we've got... So I just plugged everything in, so I've got negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times 5 all over 2 times 1. So if we simplify this, we get x equals 10 plus or minus the square root of 80 over 2. Simplify that square root of 80 and get 4 square root 5 over 2. You can reduce that, divide everything by 2, and get 5 plus or minus 2 square root 5 over 2. So in this case, you would actually have 2 intercepts, 2 x-intercepts, 5 plus 2 square root 5 over 2, and actually not over 2, over 1. So just 5 plus or minus 2 square root 5. And 5 minus 2 square root 5. So I'm just going to write them as 1. But those are 2 values that you could plot. So if you were actually trying to graph them, I would really just find the decimals here at this point of them, but you would still have to use the quadratic formula to do that. But those would be 2 x-intercepts, so it would cross or touch your x-axis twice. So same process each time. Here, guys, it's really just going to be a matter of practicing it to try and get good at it.